Assalamualaikum and good day. Welcome back to my BCN 2193 Network Technology. Okay, we are move forward to chapter 2, routing concept or module 14 in our switching, routing and wireless essential net arcade module. Okay, in this chapter, we have 5 topics that we are going to go through. Okay, number 1, the path determination. It will be explained to you how the router determine the best path in order to forward any packet or data that they receive. Okay, and then packet forwarding, how router forward packet to their destination. Next is a basic router configuration review. We are going to take a look what we have learned during previous lecture. I have done all the router basic router configuration, just a review. But in this topic, I'm going to include a routing concept within that example. Okay, next is the IP routing table. Same thing, something that has been explained during last lecture, so we are not going to go depth inside that. And lastly, static and dynamic routing. Okay, we will compare between static and dynamic routing concept. Okay, first topic, path determination. There are two functions of router. When the router receives an IP packet on one interface, so it must determine that packet frame must be forwarded out into which interface in order to reach their destination. So this is known as a routing. Primary function of the router are to determine the best path to forward packet based on information in the routing table and forward toward their destination, either the final destination or to the device that connected to that network. So how they do that? Just following or referring to the routing table. Okay, for this example, I'm sure you have seen how they display the routing table by C and L, but this example, they just only provide the C only. So this may be output from the previous version, 12 point something, but current version of iOS for our router, 15 point something, they provide two info regarding one network. As you see here, C192.168.1.0/24. This is the network, and you have a L below that describing their IP address in the interface that configured for that device. Okay, and then there is a one entry here. You can see this is S, which is S is a statically configured on that router 1. So they configure in order to go to network 192.168.3.0/24. It must go via 192.168.2.2. So where is 2.2? 2.2 actually inside this network 192.168.2.0/24. So 192.168.2.0/24 actually connected through serial 0/0/0. So you can see here in diagram, this is serial 0/0/0. So in order to reach network 192.168.3.0, you must go through serial 0/0/0. So interface that we are going to forward out actually serial 0/0/0. Okay, for the S. Okay, for 192.168.3.0. So that's how the router determine their destination through IP table. In order for router to determine the best path, they need to match as long as number of bit inside their network ID. So the minimum number of far left bit must be matched. So they try to look for the longest match. That means they look for a smaller number of range IP. Okay, the best path in the routing table also known as the longest match. So in the routing table, they have entry consists of prefix, which is a network address. As you see before, 192.168.3.0, that's a prefix. And then /24 as a prefix length. So for a router, in order to match any entry inside the IP table, so they try to look a minimum number of far left bit must be matched. But the minimum number, we try to look for a longest match. I mean, even though we look for the minimum, but we look as long as we can between the IP address of the packet and the route in the routing table. By using the prefix length of the route in the routing table, so we try to match as many as we can. So the longest match in the routing table has the greatest number of far left matching bit, which means they try to match the network bit, so as many bit as they can to destination address. So we take a look for the next slide in order to see the example. So for this example, the destination IP address 172.16.0.10. But we have an entry like 172.60.0.0/12, which means they have a 12 bit of the network ID. So you can see address in the binary. So the bold here actually the network ID. So 172 is a 10101010, the first 8 bit, and then 16 actually 001000, but they only slash prefix with a /12. So the bit that they need to match actually 001 only. So here is a 12 bit that they try to match. So our IP address 172.16.0.10 is presented here. They matched the first 12 bit, but try take a look at another entry 172.16.0.0/18. We also match with the first 18 bit. The bold one here is the first 80 bit. But we have another entry 172.16.0.0/26. With this entry, we also have a match for the first 26 bit. So here we call as a longest match. So in order to reach this network, we must go to this entry. So the router will forward to this network. So that's what we call a longest match. But try take a look with this example. Okay, here how I presented in range or in the logic wise. So take a look with the network 172.16.0.0/12. As you can see, the network ID is a 10101100.001, and the rest is a don't care, we call as a add. So it can be 0 or 1. So the range for this IP address can start from 172.16.0.0 up to all 1 is the network ID, which is 172.31.255.255. Of course, our IP address that we are looking, 172.16.0.10, are inside this range. But the range is too big. We want a more specific network. So we want the entry with the smallest range. So we take a look for another entry, 172.16.0.0/18. So we have about 8 plus 6, 14 bit for the host ID. So we have a range of IPv4 from 172.16.0.0 to 172.16.63.255. Of course, we also have a match with this network, but the range is still big. Try take a look for another entry, 172.16.0.0/26. So we have a match here because in this entry, they have only 6 bit for the host ID. So the range of IP gonna be 172.16.0.0 up to 172.16.0.63. So we do not have a big list here in order to match our IP. So our IP 172.16.0.10 can be easily found matched inside this list. So this is the best route or best path for our routing. As for IPv6, we take a look for this example. So our destination IP address, so I put all the 0 here, 2001 column 0 db8 column C000 and double column 99. So all the double column here, I put all the 0 here because we would like to try to match here. So take a look our entry that we have. First, we have 2001 column db8 column C000 double column /40. Even though our network, you can see here 2001 db8 column C000 and double column, but our network ID is just up to 2001 column db8 column C0 only, because our / prefix is 40. So our network ID is the first 40 bit here. So did we have a match here? We have a match with this. Okay, we have a 2001 db8 and column C0, but we only match the first 40 bit. Did we have any greater match, which means any longer match? So if we take a look at the entry number 2, 2001 db8 column C000 double column /48. So in here you have a 48 bit that you can match. So our IP address match with this entry. And our third entry, 2001 column DB8 column C000 column 5555 double column /64. So this network ID have a 64 slash prefix, which means the first 64 digit is a network ID. So network ID must be 2001 column DB8 column C000 column 5555. So did we match with this ID? So we are only matched for the first 48 bit and we do not match with the rest. So we cannot say this network is a best path because we do not have a match. So our best path is actually between route number 1 and route number 2. But the longest match are presented in the route number 2. So that's how we select the longest match in IPv6. Okay, how router build up their routing table? It can be through these three ways. Either directly connected network or their remote network and default route. So through these three ways or through these three items, they build up their routing table. So for directly connected network, whenever you configure an interface with the IP address and subnet mask and you change the status into active or up and up, which means you do no shutdown and connected to other device, so that network will directly or automatically added into your routing table along with the IP address of the interface. So the network will be coded as a C and the IP address of the interface will be coded as a L. Okay, for a remote network, for which network that we would like our router to add into the routing table, so we need to specify that network into our router either statically or dynamically. So for static route, we add manually. Provide the command with the network ID and will be added into our routing table. But for the dynamic routing, we just let the router learn from their neighbor, which means from other router. And then that other router will provide the info for our router and our router will add the entry into our routing table. That's we call a dynamic routing protocol. And lastly, through a default route. Okay, a default route actually a next hook for any network that does not listed in the routing table. So when we take a look from our routing table, we have a list either directly connected or remote network, but the ID that we would like to match doesn't listed inside our routing table. So we will go for default route. So default route can be entered manually or statically. Default route can be entered manually as static route or learn dynamically through a dynamic routing. So default route have a /0 prefix length. So there is no need to match any bit inside the network ID. Network ID also presented as a 0.0.0 in IPv4. For IPv6, we just presented as a double column, which means all bit is 0 and /prefix is 0. So we doesn't need a mesh. Our default route will be considered as a gateway of last resort, which means for any network ID that doesn't match any entry inside our IP table, so we go to the default route.